So there are two design approaches which are mainly used. The first approach is termed as direct approach and the second is indirect approach. So in direct approach, we calculate internal forces from the load, mean we perform the static analysis, and then compare with the material strength for proportioning. So from load, calculate the internal forces and then compare with the material strength for proportioning. For example, we have a beam. For example, it is a steel beam with rectangular cross section and it is subjected to uniformly distributed load 10 kilonewton per meter and the length of the beam is 1 meter. So under the application of this load, the bending moment will be WL square by 8, so which is 10 into 1 square divided by 8, so it is 10 divided by 8, or we can say 1.25 kilonewton meter. So now we have calculated the internal forces based on the applied load. The next step will be proportioning of the sections. What will be the section of this beam? What will be its width and what will be its depth? For example, we have decided that it should be a square section. So in that case, to resist this bending moment, we know that the stress should be equal to my over I. So the stress produced because of this bending moment is my over I. As we know that, as we have decided that width and depth both are equal, so I write here d. So from here, when we will solve this equation, so we will get the value of d. How much will be the d? So once we have d, so it means we have the cross sectional dimension, we have proportioned our structural member. So this is the way of designing structure and it is termed as direct method. So from the applied loads and end conditions, we have calculated the internal gross forces, and because of that internal gross forces, we will compare these internal gross forces with the material strength, and as a result we will get the sectional properties or proportioning of the section. The second approach for the design is indirect approach. So in this case, from the material strength and assumed section properties, we will calculate the maximum load that can be sustained by the supposed or assumed section, and then we will compare it with the applied load. It means, first of all, we will select an arbitrary section and we will also select the material properties and we will perform the capacity analysis to calculate its strength or maximum capacity. Then we will compare that capacity with the applied load. If the capacity is more than the applied load, it means our selected section is okay. Otherwise, we need to revise our section. So this is a trial procedure. For example, we have selected a section, a rectangular section of 10 by 10 millimeter, and Fy is 420 megapascal. Is, for example, P is 35 kilonewton. So we will check whether this section is, our assumed section, is capable to resist this 35 kilonewton or not. So its capacity P is equal to As into Fy. So As is 10 by 10 and Fy is 420, so it will be 42 kilonewton. So the capacity is, nominal capacity is 42 kilonewton and the applied load is 35 kilonewton. So it is greater than Pu applied load. It means okay, our section is okay.